and cool. So I'm going to go ahead and, hey everyone, this is Amy. I'm going to kick it off. Just go through our introduction and introduce the speakers for today's ESIP Cloud Computing Cluster session. Thank you everyone for joining. I'm going to post a link in the chat if I can find it. Basically, if you can go and log into that Google Doc, that has another recap of the presenters today, as well as there's a section below the presentation introduction for participants. So if you don't mind adding your name there and your affiliation, that would be super helpful just to know who's with us today. First of all, I want to say big thank you to our guest speakers, Taylor and John, from the Department of Atmospheric Sciences at University of Utah, and Cloudnine Weather, or I guess Open Snow is the name of Taylor, the company that you're with, is that right?
Yeah. So Cloudnine Weather is our LLC, and
Okay.
Better known as Open Snow or Open Summit.
Cool. So, I allotted 20 to 30 minutes for the presentation and discussion questions. I'll leave it to you guys how you sort of want to use that time. If we have time at the end, I'd like to do some announcements. Zach from Amazon, as well as myself, I want to give a little bit of an update on the cloud computing cluster plan, but there is a link there as well, and so I'll be following up on that regardless. So whether or not we get to it, I can follow up asynchronously as well. So unless there's anything else in terms of the agenda or questions, I think I will stop sharing, and I'm sorry, I'm not sharing. I will pass it off to Taylor and John for our presentation.
All right. Hey, thanks for the invite. I was just going to do some of the boilerplate and then turn it over to Taylor. And let me make sure you get things on the right screen. So actually, so are you seeing it as a presentation? I had it set up, and now of course it's goobered up. Hang on. So you're not seeing it as a slideshow quite yet, are you?
Not yet. I see the slides.
Okay, hang on. And too many windows open. And all right, I'm going to stop sharing just for a second and get control back. Give me control back. Okay. It's showing up on my other monitor, which is what the issue is, and I selected the wrong monitor to show. So one more second. And the meeting controls have disappeared. Oh man, how can, we do this all day long now in classes, and you would think that with the last day of classes today. All right, is that any better?
That looks good to me.
Okay. All right. Okay, so sorry for all that. So thanks again, Amy, and also thanks for Zach, who kind of kicked a lot of this off. I'm going to just give this quick intro and talk about the work that we're doing that started out funded by the Joint Fire Science Program, is now funded more by the NOAA CSTAR program, which is a program for applied research for the National Weather Service. And it actually started with PhD work from Brian Blaylock, who's now at the Naval Research Lab. Alex Jakes, who's on the call, has been involved, and then a number of graduate students as well. So I think most of you are certainly aware of the big data program, and And again, it's, just amazing to be able to see the data flowing, from as part of this program through the North Carolina Institute of Climate Studies that kind of provides the lubrication to get the data to the cloud providers. And again, it shouldn't come as any big surprise that we're dealing with a super large dimensional data set. We normally think of dimensions just in space, but when we're dealing with numerical model output, we're dealing with both the time that the models are initialized as well as the times that the models are validated. And so those can be of varying lengths. And then of course, what adds in the complexity is all the variables, all the levels, the type of model, and the model output files and formats. So they can be in any number of these kind of things. Now, what we started because of research that we needed to do for fire weather related applications was to use the high resolution rapid refresh, the highest resolution operational model of the National Weather Service. And it has this interior grid, the high resolution rapid refresh HER grid that covers the contiguous United States. There's another one for Alaska, and then there's also smaller ones for Puerto Rico as well. The characteristic about it is that there's almost 2 million grid points just over this contiguous domain. It's developed by NOAA Esrel and run by National Weather Service. And the applications are quite broad. So just snagging some things from WeatherBell. This is starting last evening and going out. And again, not only high resolution, but also high temporal resolution, where the output is available hourly as well as at 15-minute intervals for some selected parameters. And for us here in Utah, this is like the biggest weather event in terms of precipitation going on right now. And again, just sort of showing the accumulation of precipitation and the hourly accumulation. So we're dealing with, just for the HER, kind of an 8-dimensional problem. So we got the positions, forecast time, which itself is somewhat complicated because it's out to 18 hours, except for 4 times a day where it goes out to 48 hours. Lots of variables, lots of different ways to characterize that data on levels. And then again, the issue was it started back in 2014 and continues to the present, and will continue so for a couple of more years before it's replaced by a different modeling system. And then the file type is again sort of the choices that were made by EMC, the Environmental Modeling Center, as well as NOAA Esrel, as far as how to present that information. And again, the contiguous US and Alaska. And so, as with any operational model, it's evolved over time, and so the number of variables and number of ways that the information is presented has changed, so that the most recent versions, which just started up in December, again, roughly 2 million grid points, it's generating about 700 gigabytes in order 1,500 files per day, and that's approaching about 2 petabytes of data that's been accumulated. And so it's been traditionally stored in GRIB2 format, and which is highly compressed and highly useful for dealing with these large dimensional data sets. And then as part of the open data program, both AWS is providing access to the GRIB2 data, as well as the Google Cloud platform. So all the GRIB2 data has been there for about the last year. Now, again, the reason we got involved in this is for our own selfish purposes, but we started back in about 2015 storing the HER data, and we're the only archive of that in GRIB2 format up until when, as part of the data program, both Google and AWS started doing it. So you can see it was a data resource issue. We had 160 terabytes of space to allocate to our various projects related to this, and we started running out of room. So we're extremely thankful that we no longer have to do it locally in an S3 type space. But over time, we accumulated over 1,000 registered users and a lot more people that were coming in and accessing this because it was the only public accessible archive for the HER data. And so Brian did a number of things as far as just how to create, working with our Center for High Performance Computing, how to go through those steps of using an S3 architecture for archiving the data. And then a lot of our motivation was situational awareness. How do you deal with actually keeping the information and being able to look at what's today like relative to other times? And again, for our kind of fire weather applications, big fires like this Tubbs fire in Santa Rosa, which was extremely devastating, how unusual were those conditions? And so the concept here was to show how each one of the individual model forecasts evolved with time, and how do we compare that to some sort of climatology or any kind of machine learning application. And at the time, the only option was to throw this kind of work out to the open science grid using all the extra cycles that existed out there to be able to generate the amount of climatological information that we had for every grid point from using the GRIB2 format. So with that, then we were very excited about changing it over to a different format that Taylor will now pick up on. And hopefully you...
Let me see if I can make
Yeah.
this go a little bit more smoothly then. Okay, let's see.
Yeah, it's the problem when you had it. Yep.
Let's go with. All right. Okay, can y'all see it? John, does that look good? Is it just the slide?
Yep, looks good.
Okay, perfect. Okay, so as John mentioned, we're now using Zarr format to attempt to store and efficiently access the high volume data set that is the high resolution rapid refresh. This is kind of going to be a little bit redundant from what John just went over, but hopefully it'll still be useful, especially if you might have come in a little bit late or missed, what he said. But from the years 2015 to 2020, the only way an end user was able to access the archived HER data was through a repository managed by the University of Utah. If you wanted something further back than, I think 48 hours is what's available on Nomads. Now that same HER data is available in GRIB2 format on infrastructure as a service partner platforms like Amazon and Google, like John said. And as previously mentioned, most model data is stored in this GRIB2 format, given its really efficient compression scheme, which allows it to take a lot of data and compress it down to something that's manageable to be stored. The downside of using this GRIB2 data for data storage is the inevitable high momentum file input and output, which can be challenging for some users, given the memory and compute resources required for parsing these data files, since a given GRIB2 file is only for one time period. So it's 2 dimensions, it's one time in space. So you're going to need a lot of these files if you want to look at more times. There we go. So yeah, to address these concerns we have outlined so far, we propose an alternative file format for storing these high volume model output systems from like the high resolution rapid refresh. We were able to do this thanks to the Amazon Sustainability Data Initiative. They allowed us to convert the HER model output to Zarr format and then store it using the Amazon Web Service Simple Storage Service, or S3. These Zarr files contain all the same variables as the Her GRIB2 files, but are going to be organized into domain subsets to eliminate having to access all 1.9 million grid points for each variable that you need. For our data set, we subset a Her forecast file into a 48 by 150 by 150 data cubes, where 48 is the time dimension and 150 by 150 are your X and Y directions. These domain subsets are shown in this figure here on your right with all the black grid boxes. So each of those is a chunk or a data cube. And that covers the entire Her domain. There's 96 chunks. There's one row of chunks that are smaller than all the other ones, given the number of grid points. It didn't exactly divide by 150 perfectly. So that row that you see up there in Southern Canada, those are obviously less than 150. And then of course, for model forecasts that are shorter than 48 hours, so on your non-dominant synoptic times, those data cubes will be in shape 18 by 150 by 150. So just a little background on this Her file format if you're not familiar with it. It's a relatively new format that was developed by Alastair Miles in 2016, and it was inspired by the structure and format of HDF5. So a Zarr file format allows for the creation of n-dimensional arrays that are filled with values of any data type. These arrays can be chunked along any dimension and we can be organized into any size. Zarr is not only a cloud compatible format, like we mentioned in the previous slide, but it also has backend capabilities that allow it to work seamlessly with Python libraries such as Xarray, Dask, and Iris. So over the next few slides, we're going to detail the process of creating our Herzhar data set, which you might be familiar with Zarr, but as you know, if you're creating a Zarr data set, you can kind of, customize it to whatever your project is and what your data needs are. So the general idea is that we wanted to convert these Her surface files in GRIB2 format to become Her surface forecast files in Zarr format. Since many GRIB2 and NetCDF users are familiar with the climate and forecast naming conventions, we wanted to continue to use them in the Herzhar dataset. We chose the Zarr format for our Her dataset for several reasons, but again, just to kind of drive this point home, one of the main reasons was its ability to be stored and easily accessed in the Amazon Web Service Cloud using that S3 service. So to make these file conversions, we use Python, and then with supporting libraries such as NumPy, Zarr, Iris, Xarray, and the Amazon Web Service Boto3 Python library. Just quickly want to go through Herzhar workflow. So this is just how we create these data files. Initially, we start with a complete Her forecast. So that is 49 surface files, each containing approximately 173 data fields. So for example, if we started with the 0 UTC Her surface forecast, then we will convert that into Zarr and say, once all files are loaded into memory, they are then organized by level and variable. For example, level 500 millibars, and then your variable would be height. And then those files and variables are compressed into chunks. They are encoded using a built-in library called numCodeX, and we use the compression algorithm LZ4 with the compression level 9. And your output will then be 2 Zarr files. We separated them into one for analysis and one for forecast files. So one Zarr file for each forecast run will contain just the analysis data in case that's all you're interested in. And then the other Zarr file for that 0Z forecast will contain all of the forecast files. Something to mention, while Zarr is really great in a lot of ways and it allows you to access data much quicker than you would in, say, using GRIB2, it's not as efficient when it comes to compression and storage. Our Herzhar files require about 20% more storage space than GRIB2 files, but the hope is that you'll be able to access them and just get the chunks you need from these cloud storage services rather than needing to pull down the entire data set at once, like you might need to do with GRIB before you can subset them or get a domain subset of what you're looking for. So a little bit more on this Amazon Simple Storage service. Our Herzhar files are stored using that S3 platform, where our data is stored in a bucket structure that can contain any type of file object. Our Zarr files are organized for what we think is intuitive use, and they mimic a hierarchical structure, as you can see in this little schematic that we have here. That little container, that 3D container, represents the bucket, and then you have each file level shown as it extends to the right. So it breaks out into pressure and surface level files, or isobaric files on your surface files. Then it is broken out by day and forecast time. So just to go over some ways that you can use Zarr files and how they're really helpful compared to using other file types, I'm going to show you a few examples which stem from data that comes from this event that occurred on Labor Day, or starting on Labor Day in September 2020. As if 2020 wasn't crazy enough, we had this wild event for about 3 days, 48 hours, where there was a big synoptic low that came on shore from the Pacific and made its way across the Western US. This caused downslope windstorms to occur in Oregon and Washington, and of course in Salt Lake City. If you were in the area, we had greater than 85-mile-an-hour wind gusts. In California, it exacerbated already burning wildfires, same within Oregon. And then in Wyoming, there was over nearly 1.5 feet of snow. Some very strong wind gusts there as well. And this figure was made by one of the members of the Horel research group. Her name is Kim. She is a master's student, and so she put this together for some of the work she is going to do. So the data that we used from this case, or for these examples, came from that case that we just talked about. And we really focused on one of those domain subsets over Western Oregon. We're going to be showing you some examples of how we can use Zarr to analyze cases like this, especially for high throughput applications such as operational forecasting, machine learning, etc. So this yellow outline is the approximate area of the chunk over Western Oregon. And just to kind of orient you, in the top, near the top center of that box is where Portland is located. And then those red spots are hotspots as observed by some of the NASA the MODIS Terra satellites. And so those are the areas that we're going to be looking at as far as those strong downslope winds and spreading wildfires. Some of these use cases that we can use for the Herzhar dataset is a time series. We can look at forecast spread for a point. We can also look at spatial plots, creating a type of time lag ensemble, or looking at probabilistic guidance from even a deterministic model. And we can also easily calculate empirical cumulative distributions and determine exceedance values. Okay, so first we're going to look at a time series here, which is what you see on the left, that displays her model spread using forecasts of wind gusts from that event, that downslope wind event in Western Oregon. So for each hour from 0 UTC on September 7th to 12 UTC on September 9th, all 6 through 18-hour forecasts are used to calculate this forecast spread, which you see in the shaded gray, as well as the median forecasted wind gust for a grid space near one of the burning fires called the Beachy Creek Fire. While this plot looks relatively simple, it's a time series, you can probably all do them relatively quickly. It does require a lot of data to be accessed in order for it to be created. So if we wanted to use GRIB2 files exclusively, we would need to access over 1,000 forecast files, which are on the order of about 100 megabytes apiece. Conversely, if we wanted to use Zarr, it would only require about 150 chunks, which are about 500 kilobytes apiece. The biggest benefit of Zarr is that this entire process, including the plotting, can be done in approximately 3 seconds. You can also, you can use some of the Grib filter things that are available that I've used Grib a lot, and I've never had anything happen that quickly, especially on a single processor machine. So building off that idea of the time series from the previous slide, we can easily produce probabilistic guidance from deterministic model output. So for using the data from the previous example, we can look at all forecasts valid for a given time and create a sort of pseudo ensemble or a time lagged ensemble where we treat each member or each forecast at a valid time as an individual member. So in this plot, we show the probability of wind gusts during that event, the probability of that gust exceeding 10 meters per second at any given grid point within that chunk for the valid time 0 and 6 UTC on September 8th. These probabilities are calculated using the formula in the top right corner. And these probabilistic calculations can be made easily using the Zarr file structures, allowing for uncertainty of a scenario to be understood easier. Next, I want to quickly show you how Zarr files can be utilized for calculating empirical cumulative distributions on the fly. These distributions are very useful for determining typical or atypical conditions for a location during a specific time of the year or even a specific time of the day. As John mentioned earlier, Brian Blaylock's work in 2018 calculated similar distributions for all the Herzhar grid points using the open science grid. We kind of emulated this and calculated similar wind gust statistics for all the grid points over our Western Oregon chunk, which is about 22,000 grid points. But using our Zarr method, it only took 64 seconds using a single processor, whereas this entire process using the open science grid took considerably longer. Finally, we have some future work using Zarr applications that are already in motion. Brittany Welch, who's a PhD student in John's research group, is utilizing the capabilities of the Herzhar dataset for applications related to drone package delivery, which is a really cool and upcoming little subset of our science. She's using the Her wind speed analyses to understand how often conditions are hazardous for drone flights. So using Zarr, she was able to evaluate the U and V wind components for hundreds of valid times in just a matter of seconds. So what she was doing is she was looking at the chunk that's centered over the Chicago metro area. You can see that the O'Hare Airport is denoted there by that little star on the plot. So, and then she shaded the wind occurrence count of how many times her analysis actually exceeded that hazardous wind threshold using Zarr. So before we wrap up, I just want to give you all an idea of the status of where we're at with this Herzhar repository in AWS. Currently, the Her v4 Zarr files are being created in near real time. There is a little bit of a lag because the way that we structure our Zarr files, we have to wait till the entire model run is complete so that we can put it all into a single Zarr file. So those are being created in near real time for both the surface files as well as the isobaric analyses. We haven't decided yet if we wanted to extend this to isobaric forecasts. And then going in the retrospective direction, the repository is continuing to be backfilled for previous Her runs, which are then shown by those little yellow shaded in progress boxes that you see for version 3. And then, of course, the retrospective isobaric analyses for version 4. So just in summary, we still want to make it clear that for a lot of things, GRIB2 files remain the best option for several applications, including but not limited to initializing high resolution models, operational forecasts, meeting those forecasts as soon as they're ready. Like I said, there is a little bit of a lag when we do the Zarr conversion. And when you require many variables at many levels for a small number of forecasts or analysis times. So if you need the entire domain and you only need a few model variables and you only need, say, 2 times, it really wouldn't, there'd be no reason not to use script. On the other hand, Herzhar files are very useful whenever you're interested in sensible weather parameters only, accessing analysis values over a limited area, or validating forecasts at many lead times of the day and over numerous seasons, and also understanding or seeing whenever you can identify extreme conditions relative to what you typically see in an area, like comparing them to distributions or things of that nature. We also want to say thank you to everyone who made this work possible. A huge thank you to the Amazon Sustainability Data Initiative, who not only is hosting our data, but gave us credit so that we can process and convert this data into the Zarr format in the cloud space. Big shout out to Zach Flamig, who has been our liaison and has helped us through this entire process. Really appreciate everything he's done for us. NOAA Sea-Star, as John mentioned, they have funded our research, the NOAA Open Data Program, as well as NCICS, and which is now, I guess, CISESS. And just so you guys can check it out if you want to, we've listed all of these resources on a slide, which I'm sure you'll be able to access via, I think there's a PDF of this presentation, or John made a PDF. I'm sure it'll get sent out if it hasn't already. A link where you can access this archive via AWS and Google, description of the codes and examples using Zarr, and then archives of the metadata, and then a place where you can send questions as well. So that's about all I have. We have a couple questions if we needed to get the conversation going, or if anyone has questions and just wants to jump in on it whenever they want. So
I was going to add, one of the things that's come up, especially even in the last week, is because of the pressure on the Nomad server, which is the way the data has been available publicly in real time, it's really applied a tourniquet for access to a lot of these data streams that aren't in the open data program. And so there's going to be a lot more interest in getting a lot of those operational model into sort of the open data area. One example is, the global ensemble forecast system, which some of those runs from the National Weather Service are available, but the Canadian ones aren't. So there's what's called the North American Ensemble Forecast System. And so it's those kind of ensemble model forecasts would also be a real good candidate for being accessible via Zarr, because in a lot of cases, you're only interested in a small part of the globe, and there's lots and lots of information. These are terabytes of data from a single run.
Yeah, thanks so much, y'all. And we can certainly return to the discussion questions. I think I was just going to summarize the questions that have been raised so far, or repeat what the question answer that has been asked so far, which is how fast to create the Zarr from source, and what tooling was used, some workflow tool, or just DAS distributed. John, do you want to just speak to your answer? And maybe say
and
Iris
came amplify on it as well. I mean, what really became evident was the Iris module was a way to be able to streamline some of the processing. And what took the longest amount of time, both for Taylor and then Zach Reich, who got involved in this, and then now Alex, is how to really operationalize this processing. Being able to make the decision about what compression level to be able to use. So Taylor, you want to add to that?
Oh yeah, so basically when we were creating the Zarr file formats, we kind of took some inspiration from what they were doing at the Met Office in the United Kingdom, how they were creating their Zarr files using the Iris Python package, which was really super useful. And then as far as the compression and the so the compression schemes, like the algorithm and the compression level, that basically just was a lot of trial and error, seeing which compression scheme was going to work best for our needs. I'm sure a lot of you know how compression algorithms work. And then the compression level that we chose was basically just a trade-off between how quickly we wanted to be able to decompress the data and how much we wanted to compress it initially. So we chose level 9 to enable fast decompression, but still preserve some of the high level compression that we could do using that LZ4 algorithm.
Hey, Taylor, just a quick clarification question on that. So does the Zarr decompress faster than the Grib then?
Yes.
Yeah.
Or in my experience, it does.
So it's a little bit, the trade-off was a little bit bigger storage for faster decompression, which
exactly
totally makes sense. Yeah. Cool.
And hi, Taylor, this is Sudhir. I think I asked a similar question on that about the compression. You said like it's about like a 20% more on Grib, when you go from Grib to that, right? So, so what kind of, can you tell me a little bit more about the compression and decompression? And did you guys do any sort of like a calculations on latency when you read and write on that?
So we did. So when are you asking when we were trying different compression schemes? Yeah, we did. We did kind of some of our own like benchmark testing, and the LZ4 algorithm seemed to work the best for our uses. And again, we really wanted to emphasize the speed of decompression. Grib is incredibly efficient at storing and compressing data, and that's not something that I want to take away from it all. We just wanted to kind of highlight the fact that this data all exists in the cloud. Zarr is very compatible with the cloud, and it allows you to get the small amounts of data that you need decompressed very quickly, rather than having to take down the entire Zarr file, which hopefully you should never have to do, unless you, I can't really think of an example where you would want the entire Zarr file. So while it is larger as a whole, there shouldn't really be a time where you would need to take down the entire Zarr file from the cloud. That would probably be an instance where you'd want to use Grib instead.
Okay.
And then there was a question also about basically if you guys looked at other file format options, such as HDF5 plus HSDS, which I assume is cloud access for HDF5, Cloud Optimize GeoTIFF, and NetCDF4.
Yeah, I have to say, it was kind of a, we did some preliminary looking at options, and certainly have a lot of experience with HDF5 and NetCDF. And, there were just certain aspects of Zarr in terms of trying to create the sectors that we felt was going to be worth checking into, and then we just kind of followed it through.
What do you mean by sectors?
The chunks,
The regions? Oh, right, because you did.
And the ability to be able to then, put the chunks back together into smaller, into smaller subregions, those sort of things.
Hey, can I ask a follow-up on that? For the subregions, why weren't those just chunks? I assume there's some reason those weren't just chunks within the Zarr data set itself. Instead, why were they split into separate files? Or, what's the thought on that?
So when you're chunking the Zarr data, essentially the way that Zarr works is that it creates little tiny sub files for each chunk. That's just the way that the Zarr package works. It outputs like these little very small files that are indicated by almost like indices of where they live within the larger array. So say your top left chunk in a two-dimensional array would be named 0.0 as the chunk within that variable. And that's so that you can download just a single chunk file rather than opening, say, an entire netcdf field and then looking at the chunks that way. I really don't have a super good answer of why they exist in individual files, except that's just the way that the Zarr program was structured.
And I'll just add, so much of what we were after was to speed up the access in the context of time, so, how can, for machine learning type applications, how can you bring in efficiently thousands of times and also keep the forecast time dimension, so for the forecast files, by basically creating them as three-dimensional chunks and then being able to rapidly open all these small ones makes it a lot faster for those kind of machine learning where you're just trying to look at like model errors and how to use that information.
Yeah, I guess, yeah, I mean, I think I get it, like the fundamental, the atomic unit or whatever of the Zarr data set is the chunk, right? But those chunks are, when you write them on disk, are files, but they're like you said, Taylor, they're like thousands, hundreds of thousands, right, of these little files that constitute the data set. And when you move into the cloud, those are objects and object storage, right? But they're usually, I mean, they would be just as efficient to access if they were part of just one data set, for instance, for each variable. When you read a chunk, and it would seem like, I think it would be helpful to users to be able to just, an X-array, just extract a region, it pulls whatever chunks it needs to, and then, you're done.
Yeah, and we're, one of the ways to access it right now is sort of the support in Xarray for Zarr, opening Zarr files natively, but it's not as far, and maybe somebody is more familiar with it, but we are at a point where there isn't sort of the ability. I mean, it's easy to actually just open it into an Xarray for everything again. And what we've found is a lot of the people that are already using the Zarr files that we've created are just reconstituting all of them, because it's super easy, going to that Xarray native Zarr format. So, but there's a few characteristics in that software that would be really helpful, which is to be able to only grab, a sector. And as far as we've been able to tell, we haven't found that yet. So,
no, well, it should do that. I mean, anyway, we can take this discussion offline, but but yeah, no, it should be as efficient to do that as pulling the individual files.
Yeah, no, we'd love to chat about it. I think, because that's a big issue.
Yeah, that sounds like there could be another format potentially that it's being stored in that might work. I mean, it sounds like this worked for the use cases that you guys presented on, which is great. One thing I am curious about. So you said that it's an area of active development in terms of operationalizing this process so that it could be used in some sort of operational mode.
Well, I mean, the goal as part of CSTAR would be to, for the National Weather Service as a vehicle, especially again for more machine learning type applications, and being able to just, how are you going to be able to figure out what today is like relative to the last 10, 15 years, something like that. With the HER is a nice one to use because it's a smaller data set to be able to play around with these things. But there's a lot of other data sets that could, potentially use this kind of way to be able to do it. Because, I mean, again, right now, like with people that have relied on nomads, are constantly pulling lots and lots of GRIB2 files down locally. And the open data program, at least, for the subsets of models that are available, can bypass some of that.
Nice. Micah asked about AWS regions. Is that maybe a question that Zach could answer? The open dataset program, I think. Oh, it said that the AWS open dataset page, some of the data are in US East 1, while others are in US West 1.
Yeah, I can just comment on that, in the open data program, we don't require that the data be loaded into any specific regions. We give suggestions and things like that. So a lot of the geospatial data, meaning more like Sentinel and Landsat, is in US West 2. NOAA has put a lot of their model data in US East 1. And I think John and Taylor can comment, but I think they picked US West 1 because it was close to their local data center in Utah. So they were getting the fastest speeds there, so it benefited them. And then in general, the speeds when you're working from anywhere in any of the AWS regions aren't that bad and aren't that different. So it's usually just having it in the cloud is sufficient. And then of course, since the data is hosted in the program, there are no egress costs for anyone to be worried about with cross-region transfers.
Nice, thank you. And then Ryan, do you mind expanding on your question a little bit? You linked to a paper and asked about provenance.
Yeah, hey, sorry. Yeah, this paper says here, I'll post the quote just for provenance sake. So we're looking specifically at this sort of stuff too. So I'm really glad and thank you all for doing this. So one of the things we're kind of concerned about, we're an archive. So, data provenance and scientific reproducibility, for an exact state, it's pretty important. And it seems like NASA's done some research into this, at the state of Zarr right now. And because of the architecture and how it splits files, it seems like their conclusion is, Zarr is really not ready to, for that domain yet. So, it kind of bleeds over into like ML ops. How do I know that this model is what you ran and what I want to run? So, the question would be, having worked with this and integrated with these communities probably better than, anyone on my team has. What do you see the outlook like? And is this actually ground truth? Yeah.
Yeah, no, I think those are, and thanks for pointing that out. We haven't seen that. So this is great to see. The whole issue is this is just all coming about just in the last couple of years, so as far as, some of the people that have kind of grabbed some of the data from us are kind of viewing what we're doing as just an intermediate step. And so I think your provenance question is really relevant because people are going to take it and then create their own. And then, how do you trace it back? I guess ultimately, the GRIB2 is going to be the sort of source to it, and then how people are going to be able to describe how they've taken that and used it. It would seem like it would need to have some way to be traceable as far as explaining what you did to the GRIB2 data, because of the compression and everything else. So yeah, these are, it's not a resolved problem by any means.
This is Zach. I'd also say that, I think you should be thinking carefully about sort of what are the limitations of the actual formats, and then what are the limitations of the tools as they exist today. Since as was pointed out, Zarr is relatively new. A lot of the things that you're seeing in this space are really new, right? And so oftentimes it's more that the tools are limited and not so much that the underlying format and like the way it works is limited. And so I think as we see, more people come in and start using Zarr, I think we'll see, development of better tools that'll be able to track and answer some of these questions better, so you're sort of worried about reproducibility and things like that. I mean, I don't think there's anything that would necessarily limit you from being able to, compute a hash over a subset of a data archive or something like that to be able to get it. I'd also point out, one of the criticisms was that, Zarr hasn't been adopted as a standard by anybody, and OGC was thinking about this late last year. And so that's just another example where, all of this is a little bit immature, and I think it's evolving rapidly and quite quickly. And, I think it'll be a different place a year from now as it is today, as it was from a year ago, and so it's good. And, all the work that these folks are doing is really great and sort of advancing this and thinking through all of these issues.
And the other thing that's worth mentioning is that, I mean, Ethan could probably correct me or something, but the Unidata C library now has support for Zarr. And so, so in some sense, if you're using anything that depends on the C library, Zarr is NetCDF. and then I think they're also working on the NetCDF Java support for Zarr. Is that right, Ethan?
Yes, that one's just starting. The C is just released as a fairly new release. The Java is just starting to be implemented. But yes, the plan is for full support of that.
Yeah. Interesting. It strikes me one of our sessions, and I'm going to take a moment to plug our ESIP summer session on data formats. But it strikes me that there could be a session in there just on basically active areas of development and updates on the Zarr format itself, because this is all also in line with the discussion, or sort of the ongoing discussion about how to visualize Zarr and how to discuss and also metadata for Zarr, right? So how do you discover different Zarr data sets and variables, and in the sort of, it's a little bit outside of the standard of metadata, which is file-based, because it's a data store, right? More so, I mean, it's file-based, but it's a data store more than a file store. Yeah, so in summary, I think that we should continue to keep track of these Zarr developments. But since we're nearing time, I just want to say thank you again so much to John and Taylor for putting together this presentation and attending. Anybody else have any closing, burning questions they want to make sure get asked before we wrap up for today?
I just might mention one other thing, that with the HER, that it seems like Martin Durant is kind of experimenting with, he's got a file reference, I can't remember the name, file reference system kind of thing, where you extract the metadata from binary formats and you store that, like the chunk locations and all the metadata. And he's experimenting with accessing the HER files as GRIB, extracting the chunks from, so basically having metadata that describe the chunk locations within the GRIB files. And then the idea being that you could assemble a virtual data set of anything you might want by extracting all the metadata for those chunks, kind of like NCML-like.
Right.
So it's just sort of work in progress. I just wanted to mention it.
No, that sounds also in line with what I was saying, this whole category of Zarr updates. So this is kind of like the NetCDF chunking. If you chunk the NetCDF for Zarr metadata store, you could access the NetCDF that way without creating a separate file store. Is that what you're saying?
Yeah.
Yep.
Okay, cool. Okay, great. So there is another announcement in here from Zach on Amazon SDI announcements and CMIP 6. So actually, well, Zach, do you want to speak to that really quickly with the few
Yeah,
minutes?
sure. I just shared the blog post in the chat. And so basically this is our announcement on the availability of the CMIP6 data sets on AWS. So we have them both in NetCDF from the Earth System Grid Federation and in Zarr from the Pangeo group. So they're now available for folks to use. It's predominantly data sets that have been asked for by the community right now. So it's not like the full 20 petabytes of CMIP6 data. It's somewhat smaller than that. It's generally around sort of the scenario MIP data sets and then the historical simulations. So it's generally the data sets that people are using to try and do sort of machine learning and downscaling and things like that over the CMIP6 data. And then we also have in there's a link to our new AWS promotional credit application form. If you're doing sustainability related work and you would like AWS credits, there's now a form you can fill out around that to request them. Yeah, and then we had some other posts too you can check out in the ESIP Slack around just sort of general blog posts around the things that the Amazon Sustainability Data Initiative has done over the past few years. As sort of a nice recap and roundup, and can maybe help you all out on thinking about how you can use the cloud for some of your workloads as well.
Awesome. It's, yeah, very in line with this computing cluster and our goals. So I think, yeah, I guess in summary, in terms of, you know, announcements for the cluster, definitely check out the links that Zach shared. And also the other thing that I had on the agenda was about the ESIP Cloud Computing Cluster 2021 plan. So in addition to these knowledge sharing sessions, we have some other activities. One of them I already mentioned, which is the ESIP summer meeting. We're going to be hosting a session. Well, we've submitted a session that we hope will be included in some format, some way on data formats and advances in cloud optimized data formats that we're excited about to have continue some of these discussions about Zarr and other cloud optimized data formats. So if you have time to read over that cluster plan, please feel free to reach out or make comments. And I'm going to be following up about that probably in the Slack channel for now. But definitely would like to continue working on some of those plan activities in terms of not just brainstorming for knowledge sharing sessions, but also working on this idea of cloud clinics. So I'll let you guys read about that in your spare time since we're at time. But again, thank you everyone for joining and look forward to seeing you all next time.
All right, thank you.
Thank
Thanks,
you.
everyone.
Thanks.